Hey everyone, another day, another DSA problem. So today we're going to look at 1109 corporate flight bookings. So yeah, we have the question over here, but I think I'm just going to jump to my iPad over here so I can probably just draw it out and show you guys. So what this problem is telling us is that we have n flights labeled from 1 to n, and we're going to be given an array, which is called bookings. And each item in this bookings array kind of looks like this. It constitutes of a first, a last, and a seats value. Sorry. So what this actually means is first and last are ranges. It means from the first, the starting whatever first value is from that flight to the last flight inclusive. It tells us the number of seats that we want to book. So for example, if I had n, let's say I had n is equal to 6. And that would mean that we have flights labeled 1 to 6. And if I give something like 2 to 4, 10, then it would mean that in these 6 flights that I have, I want to start from the second flight and up until the 4th flight inclusive. I want to book 10 seats for each of these flights. So that's what it means. And now the goal of this problem is that we have to return an answer array of length n, which actually represents these flights, where answer of I is the total number of seats that have been reserved for that specific flight. Okay, so the question is very straightforward, to be honest. So the brute force is honestly very, very simple. So here's what the brute force looks like. So we're going to iterate through this bookings array, right? So we're going to go through booking, and we're going to access these values first, last, and seats. And every time we get one booking, then we're gonna loop through, and we're going to iterate from first to that last value plus 1 because it's inclusive of the last flight. And for that specific flight, we're going to go ahead and increase the seat count. So I've done I minus 1 over here because we have to return this answer array, so we might as well start from 0. But our flights start from 1 to n, right? So let's just do ni minus 1 and return the same array. So the time complexity of this is if we have m booking entries and we actually have like the range could at max be the whole range of all the flights, so that's n. So we have m into n over here and our array here, so which is going to store it. Sorry. So let's just look at that over here. So the same kind of example which I gave earlier, 2 to 4, starting from the second flight till the 4th flight, I want to book 10 seats, right? And I reserve 10 seats. So the flight 2 will have 10 seats booked, flight 3 and flight 4 all will have 10 seats booked. And now let's say we're given another booking, 1 to 3, and 5 seats each. So I'm going to go to the first flight, book 5 seats. And the second flight already has 10 seats over here, so I'm going to add 5 to this. So this will become 15. And then even for the third flight, it's going to become, it's going to turn to 15 over here. Just really sorry. So this is eventually, like after these 2 booking entries, this is what we would be returning, 15, 15, and 10. Sorry, not 15, 15, 10. It's 5, 15, 15, and 10. Okay, so as we can see, the time complexity is m into n, and this is a brute force approach. So the question is, can we do better? And turns out we can. So if you observe this problem, we are dealing with certain ranges, right? And when we're dealing with the range, we're not particularly so interested in each individual flight as much as we are interested in where the flight booking starts in that range and where it actually stops. So let's say, where does it increase? Like, I start booking from here. My bookings start increasing from a certain range. And then obviously when that range ends, it doesn't increase, right? So where does the increase stop? So that's important for us, right? And if we can actually store just that information, because right now we're going to each start of a range and then we're iterating everything through that range. But if we just access a certain value of where something started and where something ended, then we can just sweep through it once and kind of add all these values up together like a prefix sum, which is the actual solution pattern for this. So let's just look at how that's going to happen. All right. So we're obviously going to have our answer array here, and I'm going to initialize this to a size of n. I don't want to do n plus 1 because we want to return this, right? So I'm going to just do n over here. And we want to know where something starts, right? Where a certain booking range starts. Okay, so we have our example over here, 2, 4, 10. So I'm going to go to the second flight, which is 2, and I'm going to add a value of 10. And I'm going to say, yeah, from here, I'm going to start booking 10 seats. So everything that comes after it, which doesn't have a value filled, is like 3 is going to eventually take this from its prefix sum and be like, yeah, I'm booking 10 as well. So this goes up till the 4th flight, right? So that would mean that up to the 4th flight, this value of 10 needs to propagate. But from the 5th flight, I no longer want that 10 because I'm not booking it, right? So I'll go to 5 and I'll do a minus 10. I want to say, yeah, 10 was added till now, but from the 5th flight, I don't want to book those seats. So we'll just kind of subtract it to make it 0 again. So this is one booking, and then we have 135, all right? And 135 means from the 1st flight till the 3rd flight, I want to start booking 5 seats, right? I wrote that weird, but okay, so let's go to the 1st flight. We'll add 5 because from here, 5 additional bookings start. And this goes up to the 3rd flight over here. So till the 3rd flight, 5 has been added, but from the 4th flight, I no longer want to add those extra 5 that were added till now. So from the 4th flight, I will do a minus 5. Okay, so let's say we only take this example of 2 bookings. Now we're basically saying at flight 2, the seat count increased by 10. At flight 5, the seat count decreased by 10. And the same thing from flight 1, F1, the seat count increased by 5. And from flight 4, it decreased by 5. And if this is something like what we have here, if we have this as like, if we call this like a differences array, we're basically going to do like for the range left to right. For the left flight where things start, we're going to be adding this value. And the flight after where the range ends, we're going to subtract that value. Okay, sorry. We're going to subtract that value. For this range for left to right, and given that seats is value, and the right plus 1 as in like the next flight should actually exist. So in certain cases it won't. So we'll just have to do a check if it's within the limits of n and just see if we want to access that right plus 1 value. Okay, and then we just kind of sweep through this and we calculate what our actual values would be. Right, so what's going to happen here? So from this differences, I would say this would be our total answer. So let's have it for 5 flights, 1, 2, 3, 4, and 5, right? So I'm going to go to the first one here. First one is just a plus 5, right? It's going to be 5. When I go to the second value, it's going to be this plus the value before it, prefix sum, right? So for the second flight, I'm booking 15 seats. And for the third flight, it's also going to take the previous value from here. So the third flight is also going to have 15. And then the fourth flight, as you see, that value 5 is no longer there because it was from this range 1 to 3. So this is where it decreases. So this goes back to 10. And the fifth flight, again, does not have any booking at all, as you can see. So this previous booking of 10 is subtracted again here. So 10 minus 10 becomes 0. And this is our eventual answer array, which we will be returning. And what are we doing here? We're doing this in actual OFN time, right? So to actually go through bookings, so we were saying like we'll go through M bookings and actually mark all of this, and then we were sweeping it once. So what is that? That's like M plus N, which is much better than m into n. So yeah, this is the solution for how this problem is solved. And this is actually something very important because a lot of problems follow the same pattern. And we're going to solve another problem after this, which actually uses the same concept as a foundation, but that problem is much more trickier. And having solved this first kind of helped me with that. So let's just look at the code. All right, so we have our basic m into n solution over here, the brute force. Yeah. This is actually m plus n. Okay. So what are we doing here? We're going through flights, and I said our flights actually start numbering from 1 to n, but in this case, we'll take it from 0, and we'll just do an I minus 1 because we want to return answer array. So we're going to go through every flight. We're going to go to the first one where the range starts, and we will be adding seats. And as I mentioned, till where the range ends, the flight after that, the range has to the seats have to decrease again, right? So I'm just doing this kind of check over here to even see if the next value exists, if I want to kind of access that in flights, right? So I want to see if last minus n, last is actually less than n, right? So this works here. I don't have to do a last minus 1 because last is actually, since everything is like starting from booking 1 to next, and our array here actually is 0 indexed and this is 1 indexed, to last actually refers to the next value here. So yeah, we go to that next value and we will decrease it by the number of states, right? So once we do this, we have all our flight, our prefix values kind of populated. So we'll sweep through this and we will start, adding up our prefix array, right? So flights of I is basically going to be equal to whatever value was added before plus its current value. So yeah. So we are going to start from the first flight because flight index number 1, because as I showed, the 0 index is not affected by anything. It stays the same. So 1 to n would get added with the value before it, and that would continue happening. Yeah, and then we just return flights. Let me just submit this and show you guys. Yeah, so this is the optimal solution, and I hope you guys understood it. So yeah, happy coding, everyone.